All right, so for our project, we worked on generated piano music. So this is for E460J Data Science Lab in spring 2021. And first, we'll discuss the product motivation. So the reason we chose this project was that music is an interesting topic, and one of the very easy ways to approach music is through keyboard music because of its MIDI format. And some of us have musical backgrounds, and so that added a level of interest as well. But most of the music, or the majority of music, is created by a human and is artistic in that way. But we are interested in the possibility of making that a automated process where the computer learns from the humans created work and then creates original work based off of that. So the first step in this process was to select some music to train on. So there are a number of avenues here to take. The first one was to focus on specific composers and to listen for their stylistic motifs and things that they did in their work. And then some other ones were to focus on the specific styles of the piece. So maybe sonata or a nocturne or a prelude or a number of different styles that you could see in piano pieces. And then lastly, of course, is sourcing music. So there's a lot of MIDI files out there, but not all of them are free. However, some of them are. And so we were able to find some that were indeed free and of high quality. So we use that and then tried out a few different things here. So what we did is we focused on a couple of composers such as Chopin, and then we focused on a number of different styles. So mainly preludes and sonatas. So these were some different things we tried out, and you'll see later on that the intended effect, I think we accomplished it, but we'll go into that more later.
Yeah, so one of the challenges we faced was getting the raw MIDI files imported into our program and into an acceptable format for the network. To do that, we used Music 21, which is a Python library to import the MIDIs as an object. We wrote a function called getNotes, which parses the MIDIs. It looks for the piano section because that's the simplest instrument. It saves every note as a string from 21 to 108, and then saves every chord as a string in normal order format. Normal order is just a uniquely identifiable format for the chords. So you can see on the picture on the right, all the integers are notes and the floats, those are chords. And then we saved all the timing offsets to an array. And next we'll talk about our network design.
Yeah, so our network is composed of 3 layers of LSTM and then a dense layer with softmax activation. The LSTM shape is defined by the by us, but the shape of the dense layer is actually determined by the number of distinct notes and chords in the song or songs. So in this case, we have 101 dense shape of the dense layer. Means there's 101 unique notes and chords in the songs. So basically, this is a classification task. If we give the neural network a 400 sequences of notes and chords, it's going to predict which notes or chord will be played next. And then the model uses cross entropy and RMS props as a loss function and an optimizer. We use categorical cross entropy because we didn't one-hot encode the data, and then we use that to just do the one-hot encoding for us. Anything can work as the optimizer, Atom, or anything. And then briefly talk about the music generation. Since we're trained with music length of sequence 400, we also start to generate, we'll input a music sequence of 400 and let it produce the next, let it predict the next output. And then we have a total of 401 sequences. and we will take the latest 400 and let the model predict again and again and again until we have the desired amount of sequences we have.
Thanks, Yancheng. So we'll go over kind of the iteration process of how long it took to train and the process that we used to train this model. So the main approach we took to training was we tried to split it up into, seeing first how many epochs was worth training on, like when did we start to see diminishing returns. And it also mattered what was the style of the data that was input. So for example, as mentioned before, we had two main styles. We had preludes and sonatas. The preludes are significantly shorter and are also a little bit simpler for the model to digest and definitely have fewer inputs. And so they took significantly less time to train, usually about a third of the time or so. And so among the different epochs when we got on 50 epochs, it took about 15 minutes for the preludes, but the real output was quite repetitive and very simple. A lot of the time it would even get stuck on repeating the same note over and over and over until the end of the song. So we decided to bump it up to 100 epochs. And at that point, we started to get really good results. There are some very long sequences and some good variation and some complex kind of chords going on. And the training time was quite reasonable. For preludes, it was about 30 minutes, and sonatas was about 1.5 hours. And then we tried to see what would it look like at 150 epochs. It would get a little bit better, but not really noticeable, and it would just diminishing returns in terms of quality. But it took significantly longer, about an hour for preludes, and sonatas would just go on quite likely overnight. And based on our training resources, we decided to stick to 100 epochs. And so on the next slide, we can look at one of the sample kind of outputs as we're training. So you can see in this specific case, it took about 20 seconds per epoch. And we did try 200 epochs in this case, and we got to a pretty low loss, but we can see that the loss function, the loss value itself is kind of increasing and decreasing and hovering around the same numbers. So we decided that, it's kind of a point of diminishing returns at about above 100 epochs. And next we'll go over an actual output and visualize it.
Right, so it'll be nice to visualize the MIDI files in addition to listening to them. So in order to do this for the video, we use a tool called Piano VFX. That's their website right there. If we can click on that video and show how this VFX actually works. As you can see, this is the actual piano music that we're playing. Unfortunately, there isn't any audio with it, but as you can see later on in this video, we're able to visualize the songs that our LSTM creates and play some music as well. So I'll hand it off to the tools that we use to create our project.
So on this one, we'll discuss the musical interpretation of the output and the results. So as we discussed the music here, there were some very interesting features we recognized, and we're able to determine that they were in fact, very similar to the input of music. So we saw a lot of musical trends and motifs duplicated. However, and sometimes we were able to see it in a way where it wasn't overfitting at all, and but it was really high quality music output. So some of the things we saw were similar keys being represented in the output of music, such as like a B flat major key being played in many of the input songs, and there being an output song as well. So that's a similarity that we saw. Another one would be a similar motif where you might have like a lot going on the right hand and accompaniment in the left hand. And we saw that in the input and the output. Of course, not being the same piece, but a similar sort of stylistic effect as well. So those are some of the things we saw, and we were able to replicate in the music from the input to the output, which was impressive for our LSTM to produce.
So some of the resources that we used, we mainly trained on Google Colab. using local GPUs to accelerate the training process. Music 21 was the library that we used to convert the MIDI files into Python objects that we were able to use with the LSTM, as you can see on slide 4. Piano VFX was the MIDI visualization tool that you saw before that played each tool and showed the piano keys associated with each one. And the LSTM, or long short-term memory model, was a type of recurrent neural network that we use to train. And now we're gonna have a demo of the visualized output using the VFX visualizer.
Great. We hope you enjoyed the demo, and have a nice day.